Okay, so let's review this problem. As you can see, I've already marked off the 4 bar forces that we want to do. And as we mentioned in class earlier, there is a zero force member case. If you look at joint C, you can see that it qualifies for that case 2 that we talked about. So therefore, the force in CG is equal to 0, and I'll just write zero force member to remind myself. Now, the one thing that's dangerous about this is if it's not a zero force member, even though you think it is, you've just missed it. So it can be quick, but you better be sure of your observation. In this case, I'm pretty sure that's correct. So 1 down, 3 to go. So now we're going to do method of sections for this problem. So if you do imagine a cut through these 3 elements, and you have the left side or the right side, which would be have a slight advantage. I'm going to say the left side, simply because I would only have 2 forces to deal with. The right side would have 3. It's a minor difference, but all the same one to deal with. So if I'm going to look at the left side, I need to know my reaction at A. So let's first draw a 3-body diagram of the entire structure. And I will try to find my reaction. So here's A. It's a pin. Actually, it's a roller. So it has one reaction, AY. And then way over here at E is a pin, EY, EX. And then I got a lot of forces to deal with. Let's see, I've got one here in the middle, at the quarter point, and then even on the ends. I'm going to write everything in terms of kips. So these are 1 kip forces. And these are 500 pounds or half a kip. And the dimensions here are 12 feet all the way across. Another thing that you might notice in your book, your author might say that these, what he'll say is 4 at 12 feet. What he means is there are 4 spans in the structure, each is at 12 feet. That's another way of telling you the dimensions. So I'm only interested in AY. That's the only thing I need, because when I make my method of sections cut here, I'm going to work the left side. I don't really care about EX and EY. So let's just write one equation and get AY. What's the fastest way to do that? Yeah, we're going to sum moments about E. And make sure that's in equilibrium. So starting here at E, I've got 1, 2, 3 1-kip forces. They're all creating positive moment. They have different moment arms. 12 feet, 24 feet, 36 feet. Then I have that half-kip force creating positive moment, and that's at 48 feet. And then I have my AY force creating negative moment, and that's also at 48 feet. So it looks like the answer is 2. Anybody check that? I think AY is 2. Mr. Kettler gives me the thumbs up. You know, in certain countries, the thumbs up is not a pleasant acknowledgement. Yeah, that's not good too in some countries. In fact, a lot of gestures with your hands, it's best to keep your hands in your pocket in other countries. For a lot of reasons. Alright, so there we go. So now we're going to do my method of sections. So I'm going to draw my section here. So there's the left part of my structure. And then I'm going to have the force in GH and the force in BC and the force in BG. I have an applied force of 1 kip. Over here I have a half kip, and I have my reaction, which I just found, which was 2 kips. And this was 12 feet. This was 16. I can go ahead and find my rise over run, or my slope of my diagonal force. It looks like a run of 12 to a rise of 16, which is a 3, 4, 5 triangle again, conveniently. Everybody happy with that? So let me go ahead and do this. Bless you. B and H. I will also indicate that out here in space is a point G, where BG and GH are concurrent. That should give you some tips. And if you look at that carefully, that looks very similar to the example problem we just worked. So we'll follow the same strategy. So what would that strategy be? Let's sum moments first. What point should we sum moments about? There's 2 choices. Anybody have an idea? B. B would be a good place. And remember, BC, BG, it tells you B. So I'll sum moments about B. I should find GH. Where else could I sum moments? Yeah, G. I went to all the trouble to make them collinear. That was a big tip-off. So I'll sum moments about G, and that'll give me BC. And then I'm left with BG, and how can I get that? Play along. Sum of the forces in the y direction. Correct. So let's do that. So let's sum the moments about, I think we picked B first, so we'll do that one. Really doesn't matter. You can solve these equations in any order you like. The results will be the same. So summing moments about B, I have the force in GH creating positive moment with a moment arm of 16. The 1 kip force passes through B, and I got to deal with these 2 guys out here. Now, you can do these 2 forces individually, or you can look at a resultant force in this line of action. What's the resultant force in this line of action? 1.5 acting up. And that creates negative moment about B and has a moment arm of 12. So from that, I should be able to solve for the force in GH. It looks like it's going to be positive. And I have no idea what that number is going to be. Somebody help me. 1.125. Anybody else get that? That seems reasonable. So our second point we identified a moment was to sum moments about G, which is down here. So that leaves BC as the unknown, and that creates negative moment about G. It has a moment arm of the height of the structure, which is 16. And then what's left? Well, I have to deal with this 1 kip force, and then my composite 1.5 kip force. So I'll start with the 1 kip force here. That creates positive moment with the moment arm of 12 feet. And then my resultant force over here creates negative moment, so that's 1.5 kips. It has a moment arm of 24 feet. So what is the force BC? 24 and a half is 36. Is 24. What's 24 divided by 16? 1 and a half?
Yeah.
1.57?
No, 1.5.
1 and a half. And that should be negative. So BC should be in compression. Does that make sense? Let's stop and look at this. So with this loading all being basically gravity loading, the whole bottom chord of the truss should be in tension. So that means that G8 should be in tension, and that's what I got. The whole top of the cord should be in compression, and BC came out compression. So we're left with one force BG. How do we get that? I think earlier we said we were going to sum the forces in the y direction. So let's do that. So here's my free body diagram looking at forces in the y direction. I'll start with the unknown force. It will be acting down, and it's 4/5 of the total BG. What else is acting down? I've got a 1 kip force acting down there at H. And then this is a composite 1.5 acting up. So that tells me I can calculate BG as, it looks like it's a positive number. I don't know what that is.
0.625.
Point what?
625.
625. Anybody else get that? Looks like it's a positive number. Anybody else get it?
Yeah.
Yep. Okay, great. So any questions about that one? So tension, compression, tension. All right. Well, that concludes that. 12 minutes.